I'm Morgan.
And I'm Payton.
We're going to explain titration. So, why titrate? We titrate to determine the molarity of an unknown concentration of either an acid or a base.
Okay, and what we need to know before we titrate, we need to know the moles of the standard solution that we're going to use. The standard is what we know. The unknown, we're going to label the analyte. So the standard we can find by measuring the amount that we are going to use, which comes a little bit later, and we already know the molar mass. So whatever the molar mass is, you can determine the number of moles used. We also have to have a balanced equation of the acid and the base. Remember, an acid and a base yield salt and water. And so we need that balanced equation to get a molar ratio. So we need, or that will enable us to figure out how many moles of the unknown we're going to need.
And now I'll explain priming the burette. So we have a burette, and what we're going to do is we're going to take water and we're going to put it in and swirl it around and then rinse it out and do that 3 times. And then we're going to do whatever solution we're putting in the burette, swirl it around 3 times. In our case, we're going to be using sodium hydroxide.
Okay, so this is our solution that we're going to be putting in the burette, and it is below the table here because we don't want to pour above eye level. So we're going to just go ahead and put this bad boy in, and we're going to read an initial value. We're just going to read this at eye level. We're looking about 49.90, and we are, which is 1 degree of uncertainty of this burette. So we're going to begin our titration. I've already gotten the bubbles out by using a waste beaker. And here we have our unknown acid. In this case, it is a diet soda. What we're going to do is we're going to add phenolphthalein, which is an indicator. It's going to turn pink around 8.3 and up. We're just going to add 1 to 2 drops of that. And then we're going to put this under here. The stopcock should be positioned horizontally when we don't want it to come out, and we're just going to move it vertically when we do want it to come out. And we're going to occasionally swirl so that we're getting a good mix here. And as soon as the solution starts turning pink, it needs to stay pink, and it needs to be a light pink color, which we will show you at the end. So here we are swirling. I'm kind of letting it flow at first because we know that we're going to need quite a bit of base to neutralize this acid. All right. Lindsey, you want to take over?
Yeah, sure.
You let go of this one. It is always a good idea to hold a piece of white paper to be able to tell the color. Alright, so here we are. We have refilled the burette up to 50.00. She's draining it now. We are adding more. But as continued from before, we do have a stronger acid here, and our molar ratio is actually 1 part acid to 3 parts base, which is why we're having to use so much of this base to titrate this acid, why we're not seeing this pink. It's starting to show up. You're starting to see a little bit of this pink color. That's the phenolphthalein indicating the base. But as soon as she swirls that flask, that pink is going away, which means we're not done titrating yet. Seeing a more persistent color here, which means it's not starting to go away as quickly as the others. Still clear. Oh my god.
There we go.
Awesome. Okay, so this is our final result. It is contrasting with the white paper. We do have a light pink. If this were to be bright pink, we would have had to start our titration completely over. But our final volume is 6.6 is going to be our final answer, which means that we displaced Alright, it took 92.30 milliliters of base to neutralize that acid.